So on to question number 5. This is worth 8 marks, so this means that it will require a lot of working. So let's read this information that they've given us. So a particle of mass 0.8 kg lies on a rough plane which is inclined at an angle of 28 degrees to the horizontal. The particle is kept in equilibrium by a force of magnitude T newtons. This force acts at an angle of 35 degrees above a line of greatest slope of the plane. The coefficient of friction between the particle and the plane is 0.2. We need to find the least and greatest possible value of T. This is T. So first let's write down the information that they've given us. First they've told us that the mass is 0.8 kg. That means that the weight is 8 kg. So first let's, since the particle is on an inclined plane, we will need to resolve the weight. So when we resolve the weight, this will also become 28 degrees because these are parallel lines, and when we do that you get 28 degrees. So there will be a downward force component of 8 cos 28 and a horizontal downward component of 8 sin 28. Now they've told us that it lies in a rough plane, which means that there is a force of friction being applied over here. Now we do not know the direction in which the friction is acting, because we are told that the particle is kept in equilibrium. Now the rest is another important information they've given us is that the coefficient of friction, which we write as mu, is equals to 0.2. So, and let's also resolve this T Newton force. So it is acting in this direction. That means there will be a rightward component and a vertical component. So this will become T cos 35 and this will become T sin 35. So they've told us to find the least and greatest possible values of T. So we also know that there is a normal reaction acting on this particle, which will be R. So we also know that there is a normal reaction acting on this particle, which will be R. In order to solve this question, we will need to change the direction of friction to create two equations. From those two equations, we will be able to tell whether which value of T is the greatest value of T and what is the least value of T. For example, the first scenario is that the friction is acting downwards. So we know that friction always acts in the opposite direction of motion. That means that if friction is acting downwards, the particle is about to move in the opposite direction. So the downward component of the weight and the friction will be equal to this T cos 35. In another scenario, if the friction is acting upwards, that means that the particle is about to move downwards. So for example, let's create the first equation in which the friction is acting downwards. So that means that T cos 35, which is pulling the particle upwards, is equal to the forces acting horizontally downwards. That will mean friction plus this downward component of the weight, 8 sin 28. Now let's assume that the friction is moving upwards. That means that the friction plus this T cos 35 is moving the particle upwards. So T cos 35 plus friction is equal to this downward component of the weight, which is pulling it downwards. So for further clarification, I'll be writing the situation like the case in this way. So let's see. So now we have to determine which equation will give us the greatest value of t. So the first equation will give us the greatest possible value of t, since it is combining the 8 sine 28 as well as the friction. But the second equation will give us the least value of t, because this will become t cos 35 is equals to 8 sine 28 minus friction. So that will give us the least possible value of t. So now let's make the third equation for the force of friction. So we know that friction is equal to the coefficient of friction, which is they have given us as 0.2, and the value of the normal reaction, which is r. Now for state of equilibrium, there must also be equilibrium vertically. So that means, since the particle is not flying upward or going downwards, that means that r, which is acting, the normal reaction which is acting upwards, plus this t sine 35 which is also acting upwards, must be equals to this 8 cos 28 which is moving downwards. That means that the normal reaction is equals to 8 cos 28 minus t sine 35. That means friction is equals to 0.2 multiplied by 8 cos 28 minus t sine 35. Now let's simplify the value of friction. So friction is equals to 0.2 times 8 cos 28, which is 1.413, minus 0.2 times sine 35, this will become minus 0.115t. Now we can now use this value of friction and insert it into any of these two equations. So we have determined that this will give us the greatest value of t, and this will give us the least value of t. So let's first find the greatest value of t and show to the examiner that we know what the greatest value is. We will write it like this: greatest value of t, and this side will be for the least value of t. So for this will be t cos 35 is equals to friction, which is 1.413 minus 0.115t plus 8 sine 28. So first let's simplify this. So 8 sine 28 plus this 1.413 is 5.17. So t cos 35, and we're taking this value of t on the other side, it will become plus 0.115t is equals to 5.17. So let's simplify the value of t. This will become cos 35 plus 0.115. So that means 0.934t is equals to 5.17. And then we divide 0.934 on both sides, we get 5.54, or we can write it as 5.5. This is the value of t, which is the greatest value. And when we're finding out the least value of t, we'll use the second equation. This will become t cos 35 plus friction, this which is 1.413 minus 0.115t is equals to 8 sine 28. So in this case, we will keep t, the like terms of t on this side. T cos 35 minus 0.115t is equals to 8 sine 28 minus 1.413. So let's simplify this side. 8 sine 28 minus 413 is 2.34. As for this side, so cos 35 minus 0.115 is 0.704 t. So dividing this value on both sides, so 2.34 divided by 0.704 is 3.3. So t is equals to 3.3. So we'll write the final statement over here. The greatest value of t, sorry, this is the wrong spelling. So the greatest value of t is equals to, and the least value of t. So we are to round it off 3 significant figures, so this will become 3.33. And for this, so 5.17 divided by 0.934 is 5.55. This will become 5.55. So this is the end of question number 5.